Google scientists have successfully created an artificial wormhole inside a laboratory processor, and they used it to teleport a particle straight through it. Now, folding a piece of paper in half to demonstrate a cosmic shortcut is a fun classroom trick, but manipulating the actual fabric of space-time in a lab setting is a completely different reality, one that has been fiercely debated for decades. To understand how Google's team actually pulled this off, we have to rewind to the 1930s. We have to look at a bitter scientific feud, and we have to look at Albert Einstein. Einstein didn't invent the concept of the wormhole to unlock interstellar space travel. He created it strictly as a theoretical weapon to destroy the emerging field of quantum mechanics. Yet today, researchers are using that exact mathematical weapon to validate the very science he despised. Back then, Einstein's general theory of relativity was the undisputed law of physics. It established a hard speed limit for the universe, stating that absolutely nothing can travel faster than the speed of light. Then came early quantum mechanics, bringing with it a highly irritating phenomenon called quantum entanglement. The math suggested that if two distinct particles are entangled, altering the physical spin of one instantly reverses the spin of the other. It doesn't matter if they are separated by an inch or by a billion light-years. The reaction happens with zero delay. This idea of instant communication broke Einstein's strict speed of light limit. He fiercely rejected it, sparking intense public debates with quantum physics advocates like Niels Bohr. Einstein retaliated mathematically. First, he co-authored a paper known as EPR, designing a thought experiment specifically to mock the logic of entanglement. Almost concurrently, he co-authored the ER paper. This introduced the Einstein-Rosen bridge, what we now call a wormhole, as a theoretical trap designed to force quantum mechanics into an impossible paradox. He treated entanglement and wormholes as two entirely disconnected concepts, weaponized to win an argument. He had no idea he had just written down the two halves of a single universal code. 49 years after Einstein passed away, physicist Leonard Susskind looked closely at both the EPR and the ER papers, and he noticed a bizarre symmetry between them. Think about how a macroscopic wormhole works. It operates as a tunnel, taking physical matter from point A and instantly depositing it at point B. Now look at the quantum scale. Entanglement operates as an invisible link, instantly taking the properties, the raw data, of a particle at point A and transporting it to point B. Susskind proposed a theory called ER equals EPR. He argued that entanglement is not simply acting like a wormhole. It is literally a microscopic, quantum-level wormhole linking two distinct points in space. If Susskind was right, researchers wouldn't need to harness the immense gravity of a black hole to build a wormhole. They just needed a machine capable of flawlessly controlling quantum entanglement. Enter physics professor Maria Spirapoulou and her team at Caltech. They secured access to Google's Sycamore quantum computer, a machine powerful enough to process in 200 seconds what would take a standard computer 10,000 years. To test the theory, they relied on qubits. Unlike standard computer bits that use electrical signals to store ones and zeros, quantum computers use the physical up or down spin states of entangled particles to hold data. Scientists separated 7 qubit pairs into left and right clusters, maintaining entangled connections. Next, they introduced a target qubit into the left group and reversed that entire cluster spin. The data instantly vanished, perfectly materializing in the right side group. When the team analyzed the movement, they found the mathematical signatures of the teleportation exactly matched the theoretical dynamics of physical matter passing through a gravity-based space-time wormhole. By forcing quantum entanglement into a highly specific sequence, the Caltech and Google researchers engineered an artificial wormhole right inside a lab processor. They proved that the physical rules of space-time apply directly to quantum data. Let's look at the actual scale of this. Computer science experts like Scott Aronson are quick to point out that this is a simulated baby wormhole inside a processor. It is not a gaping physical tear in space-time that a human could step through. So does that make this experiment a failure, or just a digital parlor trick? Absolutely not. Modern physics suffers from a massive contradiction. The macroscopic rules of gravity, which govern massive objects like planets, completely clash with the microscopic rules of quantum mechanics. When you try to apply gravity to atoms, the math breaks down. That is the true value of the Sycamore experiment. This digital paper wormhole gives scientists the first tangible, lab-created tool to physically observe how gravity might function at a subatomic scale. Albert Einstein spent his final decades desperately searching for a grand unified theory to bridge that exact gap between gravity and quantum mechanics. He died unsuccessful, leaving the work unfinished. The ultimate irony of modern physics is that the wormhole, a mathematical concept Einstein invented out of pure spite to destroy quantum mechanics, has become the exact instrument scientists will use to finish his life's work.